Welcome to moskitoRender and IES Light support. In this video we will discuss how moskitoRender handles IES Lights in 3D Studio Max. In this scene here we have one simple object, it's a plane object, standard plane, and the second object, which is our photometric light, using a photometric web. First we are going to render with the scanline renderer. This will be our reference. And as you can see, we get this nice photometric look, exactly like our photometric web. Before we switch the renderer, we make a copy of this image, and then we switch to a different renderer. Let's try out Manta Ray, for example. And now let's see how Manta Ray renders the IES light. And as you can see, it's perfectly matching the result of the scanline renderer. So Manta Ray is able to support IES lights. Now let's switch to iRay and render as well. First thing we notice is it takes a little bit longer. However, the IES support is there. iRay perfectly supports the IES lights. Takes its time to stop the rendering, but let's switch to moskitoRender now. First thing you will notice, it's instantly there. And it supports the IES light, so we get the nice same result as the scanline renderer. So all renderers are able to do IES lights. However, there's something I want to show you. Let's assume we wanted to have an IES light that was an actual area light, which happens most of the time nowadays, so let's switch that to a rectangle with width and height. Now we want to see if we can render an area light based on a photometric web. For that we start with the scanline renderer again. Wow, what's going on here? That's not a rectangular or area light. Let's ignore it for a second and just make a copy of that rendering. And now let's switch to Manta Ray. Manta Ray should be able to do a nice area light, right? Okay, let's render this. Okay, here comes Manta Ray. I would not say that this is an area light, but again, let's just copy this picture and switch to a different renderer. Now let's try iRay. Okay. First thing we notice again, it takes some time. Also, what you're seeing here is recorded in real time. So what you see here is the actual time it takes to iterate this image. So it's one light and a gray material. Okay, let's assume this will eventually converge to something we can see, but I must say iRay is the closest to an area light here. So we have 3 renderers and 3 different results, which is interesting because IES should give you always the same result, right? Okay, let's see what moskitoRender does. Okay, let's copy the iRay picture first, and now let's render with moskitoRender. Again, you see instantly, flash, it's there. That's a nice thing. And as you can see, the moskitoRender result is the closest one to an area light. We have all the intensities, we have everything from the photometric light, and we have an area. Which the only other renderer is iRay that comes close somehow. Scanliner is no question at all, we can't use that as an area light, and Manta Ray is no area light, sorry, that doesn't work as well. So the only one is close to an area light is iRay. But the intensities are not like in the photometric web. Okay, let's move on to a different IES scene. In the next IES scene file we have here, we have a corner made out of 2 walls and 2 IES lights. Let's bring up Active Shade with moskitoRender. These IES lights are Erco lights, and we're using a photometric web. The great thing with ActiveShade and moskitoRender and IES Lights is you can adjust them interactively. So as you move your target here, you can see in real time in ActiveShade the rendering, how it happens. So you can adjust your lights really in a visual way, and this includes also the geometry. So it's not only the spots moving around. If you check out the top of the image, the geometry also moves along. So everything is updated in real time in this scene. And that allows you to really model your light as well. And by modeling light, I mean you can just click into the scene, move your spot around, and move it anywhere you want. You get instant feedback. Let's assume you wanted to have it right at the edge, at the corner of your shelf. You move it there, and you instantly see the result, the visual result in your rendering in ActiveShade. That's the power, that's the great thing about moskitoRender. You can interactively adjust your scenes, including IES Lights. Now let's move a little bit closer to our objects here, and let's turn on some secondary effects. All this interactivity also works with global illumination, which is also great. Let's turn on global illumination, and you instantly see it becomes brighter because light is bouncing around now. And you also see light is bouncing off our objects and the shelf. We can add another effect to the mix, and this is GI caustics, or caustics caused by global illumination. moskitoRender is so powerful that it can handle this even with path tracing. Let's turn on GI caustics. And you will instantly see how caustics are created on the back wall, caused by light bouncing off the shiny metal surface. And the focal points will converge slowly, and you get a really nice, natural, accurate, photorealistic rendering of your light bouncing around. It's just so powerful working with GI and caustics. And this is still interactive. You can still move around, so turning on GI didn't harm anything. You still have full interactivity. You can move around objects, you can change lights. It just works. moskitoRender is the most advanced GPU renderer for 3D Studio Max with full support of IES Lights, area IES Lights, and perfect integration into a 3D Studio Max. There's nothing like it on the market right now. Thank you for watching this video, and I hope you enjoyed it.